When we look into space, it feels endless. Stars in every direction, galaxies scattered across the darkness, a universe that appears infinite. But the truth is stranger. There is a limit to what we can see, a boundary beyond which the universe disappears from view. Astronomers call it the cosmic horizon, the edge of the observable universe. And what's unsettling is this: the universe doesn't end there. We simply can't see past it. But that boundary itself is not empty. It's filled with ancient light, the oldest signal in existence, a faint glow left over from the birth of everything. To understand why the universe appears to end, we have to go back nearly 14 billion years. In the beginning, the universe was not filled with stars or galaxies. It was something far more extreme. A dense, hot plasma where particles and radiation were locked together in a violent, opaque fog. Light existed, but it couldn't travel freely. Every photon was constantly colliding with charged particles. The universe was effectively opaque. For hundreds of thousands of years after the Big Bang, this was the state of the cosmos. No stars, no galaxies, just a glowing ocean of energy and particles. Then, something crucial happened. About 380,000 years after the Big Bang, the universe cooled enough for electrons and protons to combine into neutral hydrogen atoms. Suddenly, light was no longer trapped. Photons were able to travel freely across space for the first time. And many of those photons are still traveling today. We see them as the cosmic microwave background, or CMB. It's the oldest light in the universe, but from the moment the universe first became transparent, this radiation surrounds us in every direction. No matter where we point our telescopes, we eventually reach this glowing boundary. In a sense, it forms a wall. Not a physical barrier, but a limit to our vision. Beyond it lies the earlier universe, but that era is hidden from direct observation. And what's remarkable is that this boundary is incredibly distant. The observable universe stretches about 46.5 billion light-years in every direction. Not because the universe is that old, but because space itself has been expanding the entire time. Galaxies have been carried outward as the fabric of space stretches. This expansion means the light we receive today began its journey billions of years ago, from regions that are now vastly farther away. So when we look at the cosmic microwave background, we are seeing the universe as it was when it first became transparent, a snapshot of the earliest observable moment in cosmic history. At first glance, it looks like nothing. Just a uniform, faint glow. But look closer. These tiny ripples in temperature, mere millionths of a degree, are the only reason we exist. These aren't just fluctuations. They are the seeds of the cosmic web, the blueprint for every star that would ever ignite and every galaxy that would ever form. When you look at this map, you aren't looking at radiation. You're looking at the fingerprints of the universe's first structure. A fossil record of the moment the void began to wake up. But here's where things become unsettling. The cosmic horizon is not a permanent boundary. It's constantly changing. Because the universe is expanding, and that expansion is accelerating. Driven by a mysterious force known as dark energy, galaxies are moving away from each other faster over time. As this continues, more and more regions of the universe will drift beyond our observable horizon. Light from those galaxies will never reach us, not because it doesn't exist, but because space itself is expanding too quickly. In the distant future, observers in our galaxy may see a dramatically different universe. Instead of billions of galaxies scattered across the sky, there may be only a few visible neighbors. Eventually, even those may disappear beyond the cosmic horizon, leaving our galaxy isolated in an increasingly dark universe. This means the observable universe is not just limited. It is shrinking from our perspective. The cosmos is gradually hiding itself. Yet, even this visible region, enormous as it is, may only be a small part of the entire universe. The observable universe has a diameter of about 93 billion light-years. But there is no evidence that space ends there. Everything we know suggests the universe continues far beyond our cosmic horizon, possibly forever. The laws of physics appear consistent in every direction we observe. The cosmic microwave background looks nearly identical across the sky, which suggests that the region we can see is simply one patch of a much larger reality, perhaps vastly larger, perhaps infinite. If that's true, there may be galaxies and structures so distant that their light will never reach us, not in billions of years, not ever. They exist permanently outside our observable universe, beyond the boundary of our cosmic horizon. All of this information comes from light emitted nearly 14 billion years ago. Photons that have traveled across the expanding universe since its earliest observable moment. They have crossed billions of light-years of space, passed through forming galaxies, survived cosmic expansion, and finally reached our detectors, carrying with them a message from the dawn of time. So when we say the universe ends at the cosmic horizon, that isn't quite accurate. What ends is our ability to see further. Beyond that boundary lies a universe that existed before light could travel freely. And beyond that, a cosmos that likely stretches far beyond our observable region. The edge we detect is not a wall. It's a moment in time, the earliest moment we can observe. A surface of ancient radiation surrounding us in every direction. Every civilization that studies the sky will eventually discover this boundary, a faint glow marking the limit of observation. But very few places in the universe may ever develop the technology to detect it. And as cosmic expansion continues, that signal will grow fainter and harder to observe. In trillions of years, it may become impossible to detect at all. Future astronomers might live in a universe that appears static and empty, without evidence of the Big Bang, without visible galaxies beyond their own, without the ancient light that revealed the universe's origin. Right now, we exist at a rare moment in cosmic history, a time when the deepest signals of the early universe are still visible, a time when we can still map the largest structures and trace them back to their beginnings. The universe does have an edge we can observe, a boundary written in ancient light, but it isn't empty. It's filled with the oldest radiation in existence, a glowing remnant from the moment the cosmos first became transparent, and beyond it, the rest of the universe continues, silent, unseen, and far larger than anything we can ever observe.